remember we talked about the unit circle? And we spent an entire class period filling it out. Then I gave you the tricks, like how to do it real quick. So just small tricks. Remember, the first quadrant goes 6, 4, 3, 2. And that was like your pi ratios. 6, 4, 3, 2.
Yeah.
Right? And then I told you guys if you put 1, 0, and 0, 1, you could count 1, 2, 3, 1, 2, 3. So what I did is I went ahead and filled out the unit circle. That's what you should have on your desk. Now, I'm asking you to reference your own unit circle on your desk. I'm going to continue to reference mine. Yes, sir.
What is the positive and negative?
Don't worry about that. Positive and negative just means that the x value is positive, the y value is positive here because it's quadrant 1. This one says the x value is negative, the y value is positive because it's quadrant 2. It kind of helps you figure out which number is positive, which number is negative. So what we're going to do is trig in radians with no calculator. All right? So I'm going to take a very, very, very small sample of the unit circle. So I'm looking at quadrant 1, and I'm specifically looking at this 30-degree angle, a.k.a. this pi over 6 angle, a.k.a. the coordinate, the square root of 3 over 2, comma 1 over 2. All of that stuff came from your unit circle. Right here. I just picked this chunk. You see that? Student responds with, yes, Baker, I see it.
Yes,
So,
Baker.
here's how trig in radians works. Trig in radians goes cosine. That's it. That's the whole unit.
Good job.
Okay, it goes cosine. Cosine. This is going to be bad news. All right, cosine. So if I'm looking for the sine of pi over 6,
1/2.
the answer is 1/2.
Oh, that is.
If I'm looking for the cosine of pi over 6, the answer is, guys, that is the complexity of what I'm trying to teach you today. The only thing that you have to remember is it goes cosine. So cosine is your x value, sine is your y value. That's why I wrote it like this. Pause for student to soak it in. Any confusion, anything I can clarify? Yes, ma'am.
Is that for every single?
Every single coordinate on the unit circle.
Like on the test, he's going to give us a coordinate.
There is no coordinate on the unit circle that's not there because the unit circle only has those specific coordinates. Just so you know, your test will be the entire unit circle, but only like 5 or 6 coordinates total, period.
Do we get to use this or do we have to memorize?
No, you have to. We'll get there later. All right. You cannot use your notes. If you know quadrant 1, you know the entire unit circle because they're all reflections of the quadrant 1. All right. Now, I've been lingering on tangent for a while. The tangent of pi over 6 is sine divided by cosine.
So 1/2 divided by square root of
Pause for scoffing and throw up noises. Can you do 1/2 divided by the square root of 3 over 2 without a calculator?
Let's use 18 multiply.
So you multiply by the reciprocal. So instead of dividing by the square root of 3 over 2, you're going to multiply by 2 over the square root of 3. So the 2's cancel. And you get 1 over the square root of 3.
You can't have the square root
But she cannot have a square root on the bottom.
So you must do the multiply.
So the tangent of pi over 6 is the square root of 3 over 3. What? That's how it works. The how. I'm going to show you why it works. Okay, sometimes the why it works makes more sense. Are you ready? So I'm going to flip to a different slide. The same thing. This is the why it works. How far over did I get to this point?
1, 3, square root of 3 over 2.
I went over the square root of 3 over 2. I went up 1/2. So the sine ratio is opposite over hypotenuse. So the sine of pi over 6 is 1/2 over 1, or 1/2. The cosine of 30, or the cosine of pi over 6, is adjacent over hypotenuse, which is square root of 3 over 2 over 1, which is the tangent is opposite over adjacent, or sine divided by cosine. So the tangent is 1/2 over the square root of 3 over 2. So the only one that's going to be icky all day long is when you have to do something like this. That's the only one that's going to be icky all day long. Sometimes it's going to be nice. Sometimes it's going to be abysmally nasty. Okay? Oh, what? Yes, please, please, please.
But it's like, it's the same. Okay, so it goes negative. Never mind. I was going to be like, it's the same equation, but negative.
Okay. I want you, there's 10 questions there. I'm going to let you pick 5 of them. Any 5 you want. Now look at it and see what could be difficult, what could be simplistic. If you don't pick, I'll pick for you, and I'll pick all the easy ones.
1, 2, 5.
Whoa, whoa, whoa. Let's do number 1 first. So, for number 1, I'm trying to evaluate the sine of 2 pi over 3. So, I go to my unit circle. Boop. I'm doing the sine of 2 pi over 3. Boop, here it is, right here. 2 pi over 3. What is the sine of 2 pi over 3? Is it the first number or the second number? The second number. What are you looking for?
You forgot me.
I forgot you?
Yeah.
I forgot you walking in and you picked your own stuff up?
Oh, we're supposed to pick that up? Yeah.
Again, the sine of 2 pi over 3. The sine of 2 pi over 3. That's it. And you're done. That's the answer.
Thanks.
You're welcome. Yes, ma'am. Wait. We're looking at this one right here. And it goes cosine. It goes cosine. So this is the cosine value. This is the sine value. So you just copy that number. Okay, sorry. Does that make sense? That's all we're doing. Okay, so go back to our first set of questions. Watch this. Hey, whatever makes the learning more fantastic. Now, pick another one. Number 3. Okay, the cosine of 11 pi over 6. Go back to my unit circle. Find 11 pi over 6 right here. The cosine of that value. We're looking at this coordinate. And the x value, or the cosine value, is the square root of 3 over 2. Oh, number 6, are you sure?
Yeah, that one's easy. It's -1.
let's do number 6. This is number 3 of 5. Make sure you're using your brain here. The cosine of pi. Here's pi. The cosine value is -1. Okay, I'm going to put you on a pause. What have we done already? We've done a sine. We've done a cosine. We should probably do a tangent, Jack. That's pretty intelligent. Jack, you pick.
8.
Number 8. Now we're about to do the the tangent of 5 pi over 3. So the tangent of 5 pi over 3, go back to my unit circle. Find 5 pi over 3. The tangent of 5 pi over 3 is sine divided by cosine. So it's the negative square root of 3 over 2 divided by positive 1/2. Okay, so I'm going to write that down. The negative square root of 3 over 2 divided by So would you divide that by 1/2 or multiply it by 2? So I'm going to flip this fraction, flip it, and I'm going to do times 2. So it's the negative square root of 3. No, you regular multiply. Okay, I'll do it. I'll do it the long way. Just so you can see why it works. The negative square root of 3 times 2 is negative 2 square roots of 3. 2 times 1 is 2. So you can kind of do this like factoring deal here. So you just get the negative square root of 3. Yes,
So that's
Why do
8.
you want to flip it? Okay. Why do you want to flip it?
Because I can divide by 1/2, or you can multiply by the reciprocal. So multiplying by the reciprocal is easier. I want to do one more tangent. Number 2. Number 2 is the tangent of 3 pi over 4. The tangent of 3 pi over 4 is, no, it's not the same thing.
I'm talking like.
Okay. It is, it is the square root of 2 over 2 divided by the negative square root of 2 over 2. Okay, let me write it down. It is the square root of 2 over 2 divided by the negative square root of 2 over 2.
Wouldn't it be -1?
The answer is just -1.
Wait, is it sine over cosine?
It's sine over cosine.
Oh, it's cosine over
Because if you divide anything by itself, you get 1. Okay, the reason that it's sine over cosine, can I show you? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent, so it goes sine over cosine. And I could prove that to you, or you could just take it the way it's words. Yeah, we good there? So I did 5. That means that you have 5 more left to do by yourselves. Terrified or you're okay?
Terrified.
Really? Okay. So let's go to the second set of questions.
Oh, why are we not?
Now hold on. Can I just nerd out real quick? What are we trying to do? The tangent of 3 pi over 4? Right? So in a world where you were uncomfortable with this, I could go to my unit circle, and what is 3 pi over 4 degrees? to take them away from you in your test.
No.
But this is in radians, right? So if you try to do it in radians, and no working, because my calculator is in degrees. You have to go change it to radians. I think it's easier to change radians to degrees and type in your calculator than change your calculator from degrees to radians. Throw it out there. See what I'm saying? Be smarter than your paper. Okay. The reason I showed you that was for this. The second set of questions. The instructions say no calculator, exact values. What is this? I'll pick 3. Number 1. Not on there.
11.
11. Okay, we'll do number 11. The sine of 45 plus the sine of 135. So you go to your unit circle and find 45 degrees and find the sine value. 45 degrees, sine value. Okay? And it was also the sine of 135. Right? So I need to go add the square root of 2 over 2 plus the square root of 2 over 2. Will the denominator change if you add 1/2 to 1/2? You get 2 halves, right? So what is 1 square root of 2 plus 1 square root of 2? What? 1 square root of 2 plus 1 square root of 2 is 2 square roots of 2. Okay, what is 1 apple plus 1 apple? 2 apples. So what's 1 square root of 2 plus 1 square root of 2? 2 square roots of 2. They're like labels. Now you have 2 square roots of 2. Can the 2's divide? So your answer is just wait, watch. Are you ready? The sine of plus the sine of 135. What do we get as our answer? What did we get? Yes. Today you cannot, on your test, can I take your calculator away for this portion of the test? No, I could, but why? It's so easy. All right, let's go. But now, does anybody wonder, like, can you just do like the sine of 180? Right, because 45 plus 35 is 180, right?
No.
Well, would it work?
No, because we get the sine equation.
No worky. No worky. Okay.
What?
Okay. 2 more.
13.
Number 13. No, that's unlucky. I won't do that one.
14.
I'll do 13. I'll do number
11.
Number 13. There's 2 number 11s?
Yeah.
Yeah, there's 2 number 12s.
Yeah, there's 2 number 12s too.
Oh.
Well, I guess I'll do one of them so you can't get number 11 wrong.
Okay.
Oh, yeah.
And
So, number 13. The cosine of 300 plus the sine of 150. So be careful there. The cosine of 300,
Oh, it's on
1/2, plus the sine of 150.
1/2.
Okay, let's try, and it's going to be tough. Second set of problems. We're trying to do 1/2 plus 1/2.
1.
Yes! 0.5 plus 0.5 equals?
1.
The answer is 1.
got it now. Good.
What? You hate me?
No,
That's a test question.
that's easy.
One more, guys. You have one more.
Oh, well.
Which one?
14.
12 at the top or 12 at the bottom?
12 at the bottom.
Why would you pick that one?
Because it's the hardest
Tangents. They're tangents, right? So tangents involve a little more work. Now we have to do the tangent of 135 plus the tangent of 315. Go back to my unit circle. The tangent of 135
Negative square root of 1.
Oh, God. Okay, the square root of 2 over 2 divided by the negative square root of 2 over 2. Let me write that down. Plus the tangent of 315. Negative square root of 2 over 2 divided by negative square root of 2 over 2.
Oh, I had that wrong.
We did it on the top part. Yeah. 135.
Wait,
Well, technically.
Yes, sir, Aaron.
It's a negative 2.
So this number divided by itself is negative 1. This number divided by itself, positive 1, because it's negative divided by negative. Negative 1 plus 1.
0.
The answer is 0. Tangent of 315 is in the fourth quadrant. It's negative, negative. We'll return positive 1. Oh, wait. Yeah.
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 Negative
Yeah. For everyone gets you. Thanks, Aaron. Now let's go back and make sure I didn't screw up my unit circle. Please, unit circle. Thank you. I did. Should be positive.
Yeah, what a person.
What a monster, huh? So, do you get to use this like word search, go find it on your test?
No.
You don't. How many of you guys are already done?
Almost.
Nobody almost done? So, here's what I'm going to do. I'm going to give you your review today. When's your test? Friday. So now you have 4 days to complete 33 questions. There's really no reason it shouldn't be done, and you shouldn't get the square root curve. Okay? The only thing I have not taught you is angle of elevation, angle of depression. They will review on Thursday. They will test on Friday. So I would like Thursday to be like Baker, number 1. Baker, number 6. That way we can target our review for questions that you have. If you're not here, watch the video.
Okay, cool.
I mean, I could be like, you're not here, it sucks for you.
Yeah.
So that's the best thing. I will record the whole thing. I'll go through and pick all the questions out one by one by one. That way we can go over them. This is just practice. I would maybe draw your own unit circle and see if you can fill it out by yourself. Let me just double check and make sure. I'll leave the recording on for this. Your unit circle is missing 5 pieces. It's missing a 30-degree piece, a 135 piece, a 180, a 240, and a 270. Then I'm asking you guys to give the exact value of like the cosine of pi over 2. Can you do cosine of pi over 2? Is that an easy one? So as long as you know that pi over 2 is 90 degrees, that should be easy to fill out. The tangent of 225, and you could always do this in your calculator. They're all pretty nice deals. That's what it looks like right here. There's 5 questions on the unit circle. So you have to fill in the blanks here, then you have to answer these questions right here. Alright, so I'll leave this up it's really hard for me to get like this nice picture because it's all so compact. But there it is. Hopefully,